Okay, so today we're going to talk about perfect squares and how to evaluate square roots. The second thing we're going to talk about is non-perfect squares and how to estimate non-perfect square roots. Let's look at our first example. We have three squares here of different size, and because they're different sizes, they're going to cover different areas. Let's look at the first one. The first one we have here is 1 unit in width, and in height we have 1 unit. So this is a 1 by 1 square. So we can write this as 1 unit by 1 unit, and this will be 1 times 1 is 1. Unit times unit is unit squared. So we have 1 unit squared for that first square. Let's look at the second square. The second square is a bit larger. How much larger? Well, I'm going to show you an animation to get a good idea. Okay, so we have what appears to be 2 units in length. So 2 units, these are the same lengths here, and then it's by 2 units. So we have 2 units here and 2 units there. So we have a 2 by 2. So 2 times 2 is equal to 4, and we have 4 units squared altogether for this square here. So we have 1, 2, 3, 4. 4 units squared. Now what about the third one here? Well, we're starting to come up with a pattern now, and if we want to get the area of a square, all we have to do is know the side length, take that side length and square it, and we will get the area of the square. So for this next one, I'll just tell you it's 3 units in length. Now, what I'd like you to do is to figure out the area. So for this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 units squared. All right, or we can do 3 units, and then we'll do 3 squared is equal to 9. Okay, so that's how you calculate areas, and that's how you do squares. Next one. All right, hopefully you have this one down. So for this one, we know that the area that it covers is 4 squared, or 16 units squared. Easy. This one's a bit different, so it's kind of reversed. It gives us the area, and what we need to do is we need to find the side length. Now these are all squares, so I know that this length and this length are equal. So basically I just need to know what number times itself gives us 64. And if you're good with your times tables, you should be able to figure that out now. Have an answer? Alright, well, 64, I know that 8 times 8 is 64. 64. So the side length here must be 8, and this must be 8 as well. Now, really quickly before we go on, I just want to talk about something. When we do 8 squared, right, we go to 64. But what if I wanted to go backwards? What is the operation to go backwards? So I can't divide by 2. That doesn't work. So we're talking about squaring here. So we need to figure out a different sort of operation to go backwards. See, when I multiply a number by 2, I get that double that number. And if I want to go backwards, the best way to do it is to divide by 2. And so then I'll get my original answer. But that doesn't work for squares. So if I square a number, how do I get back to the original number? So how do I go backwards? And the answer here is to take the square root of a number. So if we square root the number, we will go backwards from being squared. So the square root of 64 is equal to 8. Next one, 36 units squared. Well, what number times itself gives us 36? Well, if you said 6, that is correct. 6 times 6 is 36, so we know that the length here is 6 and the length there is 6 as well. And I also know that if I do the square root of 36, I will get 6. So what have we learned so far? So far we know that if we square a number, we can get the area of a square. And if we wanted to go backwards from squaring a number, all we have to do is square root. So we use this little sign here, square root. All right, let's look at non-perfect squares. All right, we have this example, 2.5 times 2.5. Now this is a non-perfect square. Why? Because these are not whole number amounts. So whole number amounts would be 2, 3, 4, 5, so on and so forth. This is 2.5. So what we're going to do is I'm going to use the calculator for this as well. In order to get the area in here, we'll do 2.5 times 2.5. And this is equal to 6.25 units squared. Okay, so 6.25 units squared. I'm going to ask the question slightly different. What if I told you that the area was 6.25 units squared and you had to go backwards to figure it out? Well, we can estimate this. We can use the calculator, but we can also estimate this by looking at perfect squares. So let me show you how that works. So what I know is, 6.25 is somewhere in between 4 and 9. Why 4 and 9? Well, 4 is a perfect square, and 9 is a perfect square. 4 is 2 squared, and 9 is 3 squared. So I know that 6.25 lands somewhere in between 4 and 9. So what I know is that 6.25 is somewhere between 4 and 9. So its square root, or the number squared that will get me 6.25, we know that that number should be between 2 squared and 3 squared. Now, it's really hard to say exactly where it is, but there is a hint here, and that hint is the fact that it ends in a 0.25. So I'm assuming that whatever number we do choose, it's going to end with a 5. Let's just say it's probably 2.5, and I'll say it's 2.5 squared. So that's my estimate, although I don't know. So in this next example, we have 20.25 units squared. So what number times itself will get me 20.25 units squared? Well, I'm going to do the same thing I did before, and I'm going to look at two perfect squares on either side of that number, 20.25. 20.25 is below 25, which is 5 squared, but it's above 16, which is 4 squared. This number, whatever number it is, times itself to get me 20.25 will have to be between 4 squared and 5 squared. So the difference between 16 and 25 is 9, and so the halfway point is about 20.5. And I guess what we could say here is that the square root of 20.25, which is extend now, is it's pretty close to 20.5, so it's roughly halfway between 4 squared and 5 squared. So I'm thinking that this number is probably, as an estimate, so approximately equal to 4.5. So what I'm saying is that 4.5 times 4.5 might be 20.25. I feel pretty good about that, though, because the number ends in 0.25 here, and so 0.5 times 0.5 will give me a 0.25. So if I check the calculator, what's the calculator going to say to me? Yep, it's 4.5. So the square root of 20.25 is 4.5. So that's a decent estimate. All right, 7 units squared. So this one, again, what we're going to do, and I'm going to show you now without having a prepared number line. What I would do is I'm probably going to just make a little number line here, like this. And I'm going to go 9, so 9 is just above 7, and the next square down below that is 4. So we have a number that's between 4 and 9. This is 2 squared, and this is 3 squared. So 7 is sort of on, it's closer to 9 than it is to 4. And so I'm going to say that this number is probably somewhere around 2.6, maybe 2.6, 2.7. So it's just an estimate. We'll go 2.6 squared is probably where the square root of 7 is. So I'm saying here that the square root of 7 is approximately equal to 2.6. And that's just an estimate. I don't actually know what the exact answer is. But if we need to, we can go and check our answer using the phone. I'm going to go 7 square root, and it's 2.64, something really terrible. So square root of 7 is equal to 2.645751. I think you get the point. Yeah. So our estimate was close enough. Okay, so this is just an estimate. And how we do one last one, and I want you to try and give this a go, and then we'll check your answer at the end. Okay, and now moving on, so here we go. I know that 49 is just above 40, and we'll have 36 down here. 36 is 6 squared, and 49 is 7 squared. So what I know so far is that the square root of 40, so the length of the side of the square, is going to be between 6 and 7. So we have 40 units squared. Now I know that one side will have 49 on my number line, and on the other side we'll have 36. So between 36 and 49, and 36 is 6 squared, and 49 is 7 squared. So we know that the length of the side of this square is somewhere between 6 and 7. 40 is here on the number line, and that's about 4 units from 36, and it's 9 units from 49. So it's closer to 6 than it is to 7, so we wouldn't say it's 6.5. Squared. So maybe it's somewhere like around, I don't know, 6.2, maybe 6.3. So I'm going to go with about, I'd say that this point is probably somewhere around 6.2 squared. So something like that. So I'm going to say that the square root of 40 is roughly equal to 6.2. And so we can say that the side length of this square that has an area of 40 units squared is probably somewhere around 6.2. And just to see how well we estimated, I'm going to check the calculator, and we do 40 square root, and it's 6.32. Pretty close. This is just getting estimates. This is not about getting the exact answer. I hope that you found this tutorial helpful to estimate the square root of non-perfects and to get the square roots of perfect squares. As always, thanks for watching, and I hope that this helped.